So was that fun making the box? I hope you got a chance to make one of these boxes. Cut away the corners, open top box, right? Hopefully that was cool. So let's talk about what we did. We first talked about what it looked like to cut away an X value, not just a solid number, an X value, a variable. And then we created the formula. The formula we got was this one right here. Is that one right there. Now, what happened was we took the X height, that was the cut, sorry about the noise, and then we took the leftover edge. This is key. The leftover length, the base of this box, is 11 minus the 2 X's. And then the other one we did was up there, and it was 8.5 inches all the way across minus the 2 X's. So then this created the box, or excuse me, the base of the box. We punched this into the calculator to see what the largest volume would be. So we went to Desmos, and it looks like this, and my screen doesn't show everything. So let me try to fix that real quick. Okay, hopefully that worked. So now you can see my Desmos. I can type up the equation on the left, exactly like we wrote it out. And then here's the graph. I don't see like the top of the graph. And from our experiment, we knew that volume was going to be around an X value of 1.5, and somewhere up there was the max. So we want to see where this max is. We could zoom out. It kind of crunches this graph a bit, but then we can click and drag down, and we clicked and we found there it was. The X value that we would cut away that would give us the biggest volume was 1.585. The volume itself, that's the number you get when you plug and chug that X value into the equation. And the volume you would get is 66.148. That's the Y coordinate of the XY coordinate. After that, we went and took a look at a playground next to a building. And we decided to build the fence out straight across to make this rectangle. And we did an experiment of like what would happen if we came out with 10 feet away from the building, and we only have 200 feet of fence. Well, if we came out 10 feet on two sides, then that leaves us 180 feet across. Is that going to be the biggest area we can make? So we decided to look at, again, let's make it an X value that we come out. And then we can look at the potential area. Remember, area of this rectangle is just the 2 dimensions multiplied width and length. So we took the X, in a sense, width or length coming off the wall of the building. And then we took the leftover right here and made the equation. And we could plug and chug numbers to see how it is, but then we could take it to the graph and find the max. And that's kind of the idea. Let's take a look at a practice problem. Let's take a look at one of the practice problems. So this is the practice problem number 1 that you have on the homework. It is the schoolyard problem, the same idea. You have a building. So you're going to want to make another rectangle that's X coming out and X coming out. We want to make another rectangle that's X by X on the sides. And that's the equation we're going to give for the area. We're going to use that to get an area. So let me come back to my Jamboard to make sense of what we're doing. So now instead of 200 feet, you're going to come out X and X, X and X, and you only have 150 feet. So what is the leftover? Well, we got to take away the 2X lengths from 150. So you're going to type in the area for this idea, which would be 1 dimension X multiplied by 150 minus 2X. This is the function A of X that they're asking for in here. Once you now have a function, you can calculate what happens when X is 40 and type in the actual answers in this box down here. it does want to know what the practical domain for this problem is. And I know we're just getting used to domain, so quick hint on this and just what's practical. So for this schoolyard one, we have 150 total fence length. If I was to come out 75 feet for each side, I'm just coming back to a board that I can draw on. So if I was to come out and not come out X, but let's say X came out 75 feet down here on my drawing, what would be the leftover length that I would use for the fence on the other side? I don't think you would have any leftover. So a practical X domain, a value of X's that are realistic for this problem, we're limited to just 150 feet. A realistic domain would be one that keeps the X value less than 75 feet. That's exactly what we're talking about in the idea of domain. What X values make sense for this problem? You could also say that it doesn't make sense to have a negative X value. What's a negative fence length look like? So that's the idea of domain. Just putting some sort of sentence that says, hey, we got to keep this X value in this area. Otherwise, it just won't make sense. We won't have enough fence, per se. Let's take a look at another problem you have to do. So on this problem, they told us that this is one of those equations, very much like the Desmos one that we were looking at over here not too long ago. So this one is just a smaller version of it. So the maximum seems to peak at 15 right there. It looks like whatever this open box situation came from, we're only going to get a volume of 15. The person inside this Noah here claims that he is going to use a domain that says we should use everything from -5 to 5. Well, -1 to 5. Well, -1 means you cut away a negative length. I don't know if that makes sense. And looking at the graph, there's a couple of key intercepts, x-intercepts. There's one at 0, and there's another one over here at 2.5. That tells me that if I cut away more than 2.5, my volume might be negative. It also says that I could cut away 4 based on this graph, but I have a feeling that part of the graph is not the important part we're focusing on. I think it's just 0 to 2.5. That's the practical area of this open top box. If I come back to Desmos and show you the one we did in class, the x-intercept there was at 4.25. And the reason it was that 4.25 is if you cut away 4.25 twice, that's 8.5. That's the whole width of that standard paper. So the domain would make sense for us to keep the x values between the ones that we can cut away. So by this one, I think it might be like between 0 and 2.5. I think we already answered part B. What's the maximum volume? We talked about that. And then the last one, you have to build a 10 by 10. A box out of a 10 by 10. So you get to do another box, okay? So you're going to do the same thing we did here, but instead of it being an 8.5 by 11 piece of paper, it'll be a 10 by 10. So the equation you should have should be almost identical to this. And if you put that, if you plug and chug a value like 3, you'll be able to get a volume. You'll be able to get a volume. I hope this helps.